So I have a farmer that has 80 meters of fencing to enclose a rectangular pen, and here's our picture of our rectangular pen. L is length, W is width. And for number 1, we're supposed to write the area of the pen, given that its width is W. And then for number 2, we're supposed to find the length and width of the rectangular pen with the greatest area. So the first thing I'm going to do is go back to the information we're given. First of all, we know that the farmer has 80 meters to enclose the rectangular pen. Enclosing it means the perimeter has to be exactly 80. So perimeter means add all 4 sides, so 2 times the length plus 2 times the width, and we know that it has to be exactly 80. So 80 equals 2 times the length plus 2 times the width. So for number 1, we're supposed to write the area. So area has a formula. Area is length times width, but if I notice all 4 answer choices do not use the variable L. So we have to replace this L, and we have to replace it and write it in terms of the width, because if you notice, all 4 answer choices only have the variable W in it. So I can actually replace L and write it in terms of W, because this equation can be modified and I can solve for L so that I can replace L in my area formula. So to solve for L, 80 equals 2L plus 2W. I want to get L alone. So I'm going to isolate L by first moving the 2W to the other side. So subtract 2W from both sides. So I'm left with 80 minus 2W is equal to 2L. One more step to isolate the L. Divide both sides by 2. So I have L is equal to, well, both of the terms in the numerator need to be divided by 2. So I need to take 80 and divide that by 2, which is 40. And I need to take negative 2W and divide that by 2, which is negative W. So this is my length, 40 minus W. So now I can rewrite my area in terms of the width. So area is equal to, instead of L, I'm going to replace that with 40 minus W, and that's multiplied by the width, W. And if I look at my answer choices, I notice that they distributed the W to both terms. So we're going to distribute our W here. So 40 times W is 40W, and W times negative W is negative W squared. So the area in terms of the width is 40W minus W squared. So that would be answer choice D. The next thing we need to do is find the length and the width of the rectangle with the greatest area. So if I'm going to erase this so I have some more room here. So far I have my area formula, which is 40W minus W squared. And I need to find the length and the width with the greatest area. So I'm trying to maximize my area over here. So if I'm trying to maximize my area, I notice that this equation is a quadratic. And because the W squared is negative, that means it is going down. So if I'm trying to maximize my area, I'm trying to find the vertex here, because the vertex is the highest or lowest point always. So this would maximize my area. I need to find what width and what length I would have to maximize that. So in order to find the vertex, there is a formula, opposite of b over 2a, to get the x coordinate. So a is the number in front of the w squared, which is a negative 1, and b is the number in front of the w, which is 40. So the opposite of b is 40, the opposite is negative 40, and that's all over 2 times a, and a is negative 1. So negative 40 divided by negative 2 is 20. So far, the first coordinate of my vertex is 20, but I need to find my y-coordinate because that would be my max. So to get the y-coordinate, you take the 20, and you're going to plug it in for each w in the first term and then the second term. So I would have 40 times 20 minus 40, minus 20 squared. So 40 times 20 is 800, minus 20 squared is 400. So this would give me an answer of 400. So there is my maximum area. So my max area is equal to 400, and that happened when the width was 20. So far I know the width is 20 meters, and if the maximum area is 400, so area is length times width. If the max area was 400 and the width was 20, right? If I plug in 20 for L, I could find the length. So all I need to do is divide by 20. So the length is also 20. So in fact, the max happens to be a square, 20 by 20. So we could check to make sure that the perimeter is still 80. If you add all four sides, 20 plus 20 plus 20 plus 20, or 20 times 4, you do get 80. So the perimeter is 80, and then the area would be 20 times 20, which is 400.